Want to become pro in the sequential circuit? Then please follow this video. So here we will be starting our discussion from the latches, flip-flop, and then we will be continuing to the counter, register, and everything we will be discussing here. So stay tuned and watch the video fully to get pro in the sequential circuit logics. So latches and flip-flops are nothing but an 1-bit storing element. So which is an 1-bit storing element. Okay. So 1-bit storing element. It contains two outputs that is complement to each other. So since it has two stable outputs, so most of the time we call these as a bistable multivibrator. So whenever there is a two stable outputs are going, so we usually term this as a bistable multivibrator. Okay. So it is used in many applications like frequency division, key debouncing, everything is there. So I will be explaining one by one going over the lecture. So please stay tuned. So latch is a level trigger. So LL. So we can remember like this. So level trigger means whenever there is a transition of level from 0 to 1, whenever there is a transition from 0 to 1 or 1 to 0, then that level only it will be trigger. So that is level trigger. Okay. So level, whenever there is a change in level, means here that is a top and it comes down. So here it is there whenever level change. So here only it will be enabled. Okay, and here only it will be the changes will apply. But flip flop which is level triggered. So flip flop is level trigger. Sorry, edge trigger. Flip flop is edge triggered. Sorry. So flip flop is edge triggered. So whenever there is a transition edge that is happening, it will be triggered. So for example, it is going like this or it is coming like this. At this stage, I am marking the arrows, right? So at the arrows only the transitions will happen. So if it is 0 to here, here only after the stable change only it will. But in flip flop, while it is going upward, it will be changed. So that is what the quiet difference between everything. So let us first start our discussion with the SR latch. So many things is there. So we'll be first seeing the latches and we'll be converting that same discussion into flip flops. Okay. So first, let's start using with the NAND gate. So here we are going to develop one 1-bit memory storing element that is with the NAND gate. Okay. So we know that how the outputs are changed in the NAND gate. So we have already discussed the Boolean things, right? So let's fix one output. Sorry, one input that is A. So A. So here 0 and here 1. Okay. So this is disabled input. So whenever any one of the input is 0, output will be 1. Whenever the input is 1, then output will be toggled version of that one. Okay. So this is what the logic you need to remember in the NAND gate. Okay. So let me draw a SR latch using NAND gate. Simple. You need to take one flip to NAND gate. Okay. So let's connect an input. So this is one input. This is another one input. So this is let me complete it. So this is 0. So this is 0. Okay. Okay. So we could take output here, and this output need to be fed back to the same. So here the thing. So it will be taken from here. Okay. So here also is the same. It will be taken from here. I hope it's you guys able to get it right. So this is how we will be working here. So let's take a condition. So this is S and this is R. So this is Q and this is Q's complement. So this is how the latch flip flop everything will be. So here you can see one version is a complement of another version. So there is a two stable output. So that's why we calling this as a bistable multivibrator circuit. So let's take initial condition. So let me first use white pen. So initial condition that is 0. Here we have to consider the initial condition is 0 and 1. Okay. So this is what initial condition it has. It will be always complement. Here 0 means 1. Here 1 means it's 0 because this is Q dash. Okay. So let's take an input. So let's give an input S is equal to 0 and R is equal to 1. So this is actually already existing. The 0 and 1 is initial condition. So let me write it. This is initial condition. Okay, so what will happen? This 1 will be readily available here. This 0 will be readily available here. So when any one of the output is 0, then output will be changed to 1 according to this logic, right? So let me use a red pen. So if we are giving 0 and 1, this is the first trigger that we are trying. So then what happen? The 0 will be changed to 1. Okay. So here any one of the input is 0. So here also that 1 will be changed to 0. So this is the first thing. Now what will happen? The 0 will be readily available here. The 1 will be readily available here. Okay. Let me use blue pen here. So next output that what we are going to use is the 1 and 0. Okay. So we know here. So whenever any one of the output is 0, then the output will be toggled. So here the 0 will be changed to 1. So here both the input is 0. So the output will be again toggled to 0. Okay. So this is the condition how it will take. So now 0 and 1 is the initial condition. So let's take a green here. So let me apply this 1 and 1, that is the input. So now the 0, I think here 1 and here 0. So this condition will apply. So I'm taking these values from here. So because this is wired connection, right? So that's why it's readily available here. So when we are giving 1 and 1, so here both the input are 1 1. So this will be again changed to 0, and that is a 0 and 1. So this will be again changed to 1 only, because that is a 1 0. So this will be toggling. So 1 0 the condition. Okay. So this will be same. So here if you see, here there is a transition, but here there is same. So at the last flip flop we haven't seen any kind of changes here. It's okay. So that's one thing. So now let's bring all this concept into a table. So let me draw a table here. So I hope you guys are able to understand, right? So this is simple logic. So 1 and XR 1 means 1 into 1 there is 1. So 1 XR is 0. So 0 into 1 that is 0. So 0 toggling this is 1. So that's why the simple truth table only we have manipulated. So let me draw a truth table. Okay, so this is SR. This is input. SR. This is Qn plus 1 because we are predicting next state. Okay. So Qn plus 1 bar, because we are taking the condition of previous state, current state, and we are predicting the next state. Okay. So input will be 0 0 0 1 1 0 1 1. So here we have clearly see when the input is 0 1, the output will be changing. So let's take first, if we give 0 0 as an input, then if we consider the thing that, so if it is also 0 and it is also 0, then what will happen? Our ultimate output will be 1 and 1. So this is not possible because this version need to be complement to each other. Okay. So this version won't work. So whenever we are giving 0 0 output, then output will be 1 and 1. So this is invalid. So in any kind of latches, this condition is not possible. So if we are forgottenly or mistakenly given this output, then the output will be considered as invalid and that will be stuck there. So because this, if you think Q bar need to be complement. So if it is same, then that is not a good thing. Okay. So when we are giving 0 and 1, so the red output, right? So when we are giving 0 and 1, output will be 1 and 0. So red. So this is red one. So next one is blue one. So blue one is 1 and 0. Then output will be changed to 0 and 1. Right? So whenever 1 1 we are giving the output, then the output will resembles the same. So instead of writing same, if it is 0, it will be 0. It will be 1, it will be maintained the same. So instead of making that, I am writing Qn and Qn bar. Okay. So here you see the next state is set to 1. So this condition is called set state, and this is reset state as it is changing to 0, and this condition is set to be no change. Okay. So these are the 4 states that we are getting in a SR, which with the SR latch with the help of NAND gate, right? So this is how. So this truth table and this circuit only can be represented in a black box. So that black box, let me write it here. So this is what the latch circuit that we can talk about. So here S input that is given, R input that is also given, output Q and output Q bar. Okay. So this is latch. This is Q. So this is Q. This is Q bar. This is S, and this is R. Okay. So this is latch. So this is how this circuit will be presenting inside. Okay. So that is how we will be doing. So we can this is active high circuit. If we need to make this as active low, then what we can do is that we need to add a toggle, the toggle button here. So if you are adding toggle button, we can add OR gate here, the complement of this one. So this one is called as active low. Okay, so this one is active low input SR latch. Okay, so I hope you guys are able to understand this thing. So here we are using the NAND gate. So similarly, the SR flip-flop can also be prepared using NOR gate. Okay, so I'm leaving this to you guys, so you try as a homework. So let me directly write the truth table, so that will be quite easier. The same thing, but you guys know that the NOR gate and the NAND gate will exactly opposite to each other. So the same thing will come here, so you guys can fill the truth table. Okay, so I'm leaving here. So this is q n plus 1. So let me not write a complement because that is an exact opposite version, right? So please pause the video here and try to complete the truth table, because I have clearly said that truth table is exact opposite version. So there what happened, when we give 0 0, the output is what? Invalid. But here that will be no change. So here the same. So 0 1, what will happen there? There will be set. Here will be reset. 1 0, there will be I think there will be reset. Here there will be set. 1 1, there is no change, but here 1 1 will be considered as an invalid. So invalid, I am representing that as x. Okay, so invalid can be represented as x. So the same opposite version. So this is why I am leaving this to you. So you guys can try to build that one. Okay, so I am giving that to you. So reset, set, and invalid. Okay, so even this can also be written in a black box logic. Okay, so here if you see, this is when S is 0, output is reset to 0. When S is 1, output is set to 1. So we consider this as an active high circuit. So that why previously we used the active low logic here, because when S is 0, output is opposite. So that's why we toggle and added an active low circuit here. But here this resembles the same as S. So we will be using this as an active low circuit and this as an active. This as active high, that as active low. So this is latch. So here we'll be directly giving the input S and R. So this will be called as active high SR latch. Okay, so whenever we are using the latch, if the latch is mentioned like this, then there is an OR gate inside. So if there is a complement in there, so that there is a NAND gate inside. Okay, so one of the disadvantage in this is that there is an invalid state. So presence of invalid state is the disadvantage here. The presence of invalid state. Okay, and no control inputs, right? So there we can't control anything. So just based upon the input, we are getting output. So nothing in input control. So that is happening. So this is what the disadvantage that we are having. So these are a disadvantage that we have. So these are the disadvantage of latches. Disadvantage of this thing that we have saw now, right? Okay. So I hope you guys able to got some idea over here. So I'm leaving this here. So I am stopping the SR latch discussion here. So in the next lecture, we start about flip-flops. So latch, that we have some idea. So even the latch that we have, SR latch we discuss. So next thing we will be discussing on SR flip-flop. So that will be where we can overcome these kind of drawbacks. Okay, stay tuned guys. So like, share and subscribe the channel.